Hi, my name is Madison Robichaux.
And my name's Maya Girding, and we are members of Team 12, and our project is the sorting conveyor belt. So the objective and motivation for this project was just to create a conveyor-based sorting system that utilizes image recognition software to accurately identify and separate various manufactured items into their designated containers.
So, looking at our project goals and deliverables, this is separated into two milestones and then our final deliverable. So, for milestone one, we wanted to have our 3D models measured and designed to fit the conveyor belt. And one of our team members, Andrew, was in charge of our 3D models. We also wanted to ensure that our conveyor belt runs and stops at the user's discretion at a speed of one. The conveyor belt was really worked on by one of our team members, Gabe. And then we also wanted to ensure that the brake beam stops the conveyor belt for 20 seconds. And then we also wanted to implement a working e-stop to our conveyor belts and also successfully program our servo motor.
And for the e-stop, that was our team member Ben, and then I have worked heavily on the servo motor as well as other team members as Gabe and Ben have done a lot of work for that as well. And then in our video that we will insert within this presentation at some point, you will be able to see that all of the deliverables under each milestone or deliverable have been met.
Looking at milestone two now, we wanted to ensure that OpenCV works with our Raspberry Pi and Logitech camera. All of our software was done by Caleb with the OpenCV and all of our image processing. We also wanted to make the camera properly recognize items being inputted within 10 seconds. We wanted to implement another 3D print to hold our brake beam sensor. We also wanted to have the camera process the object being stopped in a timely and efficient manner, having our object come to a full stop for 10 seconds. We also wanted to implement and program our load cell. The load cell was mainly done by me as well as Ben, and all of our other teammates contributed heavily. Looking at our final deliverable, we wanted to combine all of our hardware components together and have the system go from start to finish within 1 minute. We also wanted to have our image processing work to scan correct objects and send the correct output to the sorting system for a total of 1 minute and have three possible outputs. Finally, we wanted to have our sorting mechanism spin in increments of 45 degrees with our servo motor to position for the output.
So here you can see how we implemented our project in real life. We have our sorting mechanism, which is that four-quadrant box, which is sitting on top of sort of a lazy Susan situation with our servo motor at the base of that, which is how it's able to spin. And then you can see our conveyor belt with those 3D printed pieces. Thank you, Andrew, holding up our camera. And then our linear actuators and everything are in the background there, as well as the load cell, of course. So here you can see our item is a rubber duck and it's placed onto the load cell and then pushed onto the conveyor belt by the linear actuators, and the conveyor belt is moving and then it is stopped when the rubber duck comes across the brake beam sensor. And then the block diagram just kind of shows you the background of our project and how we thought through it. So obviously the user places the item onto our load cell, and then from the load cell, whether the user wants to sort by weight, color, or characteristic, it will either be passed on to the conveyor belt or off into our little discard bin. And then on the conveyor belt, it will pass through the brake beam sensor, which will then stop the conveyor belt for about 1 second, and then it will take a photo. And then using OpenCV, we were able to implement this image recognition software to be able to recognize what the item is, and then obviously it is passed along into our sorter depending on its characteristics. So for the hardware design, as opposed to the requirements, this is actually how we implemented it. So our load cell ensures proper weighted items go into the conveyor belt, whether that be if it's under a certain weight or just within a certain range of weight, it's going to be passed on to the conveyor belt. And that is done by the linear actuators. And then our conveyor belt moves items through the system. Obviously, at user discretion, it can be stopped with our e-stop. And then the brake beam sensor does stop the items underneath the mounted camera so that we are able to take a photo of said item. And then, as I just said, our Logitech camera takes these photos and OpenCV is used to process the items. And our servo motor, which holds up that four quadrant box at the end, is able to rotate depending on how our camera understands each image. And then our Raspberry Pi is just how we integrated all of these parts together.
For our software design requirements, we had that our image processing must take no longer than 30 seconds. And like Maya had said earlier, it takes way less than 30 seconds now. And also our sorting method must spin in increments of 90 degrees. So the user can choose 3 different ways that they would like to sort. They can sort by weight, they can sort by color, or they can sort by the type of object. So we have 3 different flow charts showing that these flow charts were made by Caleb to help us understand our software side of things.
This is our sort by weight flowchart, and this is just kind of a little depiction of how our software and how our system understands how to sort by weight. And then following this flowchart, you'll see the sort by color flowchart. And again, it's just a depiction of how our system kind of goes through this sorting. And then obviously the same thing for sorting by like the characteristic or type of object.
And for our color detection methodology, so OpenCV is used to detect which color an object is. Our HSV color ranges are defined in our program, and we capture the frame. It's converted from BGR to HSV, and then we have our hue, saturation, and values. Our binary color mask is applied based on the previously defined color ranges. So we calculate the average color amongst all the pixels, and then after that, we use our Euclidean distance from the average color to the color range and print the closest color to that. For object detection methodology, the objects are detected using the RoboFlow API in conjunction with OpenCV. We take a picture of the object and save it, and then send the image through the API and set the specific values, like the confidence, the overlap, and the image path. Then we convert the returned image to JSON for easier parsing. Then we grab the prediction data and convert the percentage to a whole number, and we return a true or false value. And whether the number is above or below is a predetermined value.
So for the results of our project, we were very close to our expectations, and there were obviously some slight fine tuning that we needed to do through trial and error. In terms of hardware, everything was built to our specifications and needs, as I said before, if not, far exceeded our expectations. The load cell was able to weigh items to the user specifications through a GUI. The linear actuators successfully pushed items to the desired positions based on the input. The conveyor belt moved as expected. The brake beam and camera acted simultaneously and took a picture of the item. The servo motor managed to rotate to the desired position for the output. The e-stop and relay successfully stopped the system under required conditions. So as I said, all of these things were met, and it's exactly what we wanted to do, which is awesome.
Some challenges, though, we did face a lot of challenges, especially in the beginning. Our biggest issue we experienced was with our Raspberry Pi and SD card corruption. Our SD card would constantly get corrupted, and we would have to keep rebooting it. And we remedied this by transferring the content to a USB thumb drive from the SD card. This way, it was able to offer a more reliable and stable storage option. After we switched to that USB thumb drive, we did not have any more problems with our SD card. Another issue that we came across was our sorting mechanism. At first, we planned on having a rotating slide with stationary bins, but we realized that that slide was just going to be too hard to implement. So instead, we have our servo motor rotating on that lazy Susan So basically, we do not have stationary bins anymore. And yeah.
Those are pretty much our two biggest challenges throughout the project. So here is the final video of our project working from start to finish. And as I said before, the rubber duck is our item placed onto the load cell, pushed onto the conveyor belt by the linear actuators. The brake beam sensor stops the conveyor belt. The camera takes a photo, and then the item proceeds down the conveyor belt and is passed into our sorting system.